because I just get the numbers out of my calculator. Okay. Now, if I go out 2 standard deviations, I cover 68% plus some more. I get 95% of the area under this curve. And if I go out 3 standard deviations, I get 99.7% of this curve. Okay. So 99.7% of the density of this curve, 99.7% of the area of this curve, or the proportion represented being 0.997. And then 0.95, 0.68. All right, so now we're going to play a little bit with this curve. Got those numbers down? Write those numbers down. Because now I want to do a new drawing of it. Good, all right. I'm so glad you're good. It's good that you're good. All right. All right, so here's another one. Here's my mean. I'm going to do my little sections off of 1 standard deviation, 2 standard deviations, 3 standard deviations, and I am attempting to make even marks across my scale here. So if I'm going up 1 standard deviation, it's about the same distance as going up 2 standard deviations. You know, like I'm trying to do an even scaling here. It may not look like it so much. And because the way I'm writing, it looks like my tails come up here. They don't. They go down. It's just hard for me to draw them exactly perfectly. Yes, ma'am? Yeah. It's about infinities. It's about limits. Did a little bit of that in pre-cal last year, right? A little bit of talk about limits. It's about limits. That curve never actually gets to the x-axis. It hovers above it. There's an asymptote there. But the limit, as that curve goes to infinity in both directions, the area under the limit of the area of that curve, it ends up being 1. So that's a lot of theory, a lot of stuff in the class. Okay, so now I'm going to mark off some parts here. I'm going to put a line straight up at that mean, even though it doesn't look like it's going straight up. And I said that 68% of the area was between minus 1 standard deviation and plus 1 standard deviation. So what percent of the area is going to be in this little chunk right here? 34, half of 68. So sometimes it's easier to see it right there. Okay. Now, how can I figure out what's in this little piece over here? 95 minus 68 is how much? $27? Divided by 2, and you get, what is this? 13.5. Okay, for those of you who went, what did they just say? All you need to do is verify that 13.5 plus 34 plus 34 plus 13.5 is 95, and we expect 95% in all of that. Okay. Last 2 little sections, well, these little sections up here that go between minus 3 standard deviations and minus 2 standard deviations. So how do we calculate that number? Take 99.7, subtract off the 95, which is divide that by 2 and get 2, let me write it up here, 2.35, and this one's going to be 2.35. How much do I have left in the tails there? How much do I have left from here to negative infinity and here to positive infinity? So I take 100 and I subtract 99.7 and get how much? No, I take 100 and I subtract off 99.7. I get 0.3. Divide that by 2, and that is 0.15. So these areas have 0.15% of the total area. Okay. So I'm going to move on here in a second. I think it's important to have that diagram down when you're doing some things. Okay, I will bring it back up. There we go. All right, so now let's see where we're going to use this. So I'm going to say that women's heights are normally distributed. Oops. And a lot of things are normally distributed. When you talk about very large populations, you talk about SAT scores. When you're talking about any kind, most standardized scores, machine operations, generalities about how people do things, you get a normal distribution in a lot of cases. So, and the mean height from the homework was 64 inches, and the standard deviation, they said, was 2.7 inches. Okay, so since those heights are normally distributed, I'm going to draw a little normal distribution. Not bad. Okay. I'm going to put the center in. I mark the center after I draw the curve. And that center is 64 inches. I look for that inflection point. I'll just make one up. Plus or minus 1 standard deviation. So plus 1 standard deviation would be how many inches? 64 plus 2.7. 66.7. How about subtract 1 standard deviation? 61.3. All right, let's go out 2 standard deviations above and below the mean. So add another 2.7 to 66.7, and what do you got? Subtract another 2.7 inches from 61.3, and you get. Go out 3 standard deviations. Add 2.7 to that 69.4, and you get, there's our 6 foot tall woman, and minus 3 standard deviations, take another 2.7 away, and you get okay. Now I'm going to ask you some questions based on this diagram, those numbers, so hopefully you still have them. I'm going to ask you, what percent or proportion of women